8.1, guys, here's the warm-up. It says in the diagram below, what is the slope of the line passing through the points A and B? Please go ahead and put me on pause and then resume once you figure out what the answer is. This question shouldn't be hard at all. Just start at one of the points that they give you. You can always end at the other point, or you can find somewhere else that it will hit exactly. Here and here and here. So if you go and you do it a little bit quicker, you would go up one to the right two, up one, and then to the right two would be positive, which is the same thing as going up 1, 2, 3, 4, to the right 1, 2, 3, 4, 5, 6, 7, and 8. And know that 1/2 is equal to 4/8, so the slope of that line connecting points A and B is 1/2. Adding and subtracting polynomials, lesson 8-1. Polynomials in Greek or Latin is many numbers. Classifying polynomials, when they ask you to classify, know that a monomial, mono means one and nomial means number, so it's one term. Binomial, bi means two, nomial meaning two numbers, so we have two terms. Tri refers to three, nomial, three terms. Okay, if it gets higher than 3 terms, like 4 terms, 5 terms, 6 terms, then we just use the word polynomials. A degree of a monomial is the sum of the variable's exponent. So for example, if I give you an example of a monomial, like 4y to the 5th x, the degree, I'm going to abbreviate that, is equal to the exponent's sum. So 5 plus 1 would be 6. A constant's degree is 0, and 0 has no degree. So keep that in mind as well. Like the constant of this is actually, you don't include it. Down below, the degree of a polynomial, which would refer to anything more than one term, is the term with the largest exponent. It got cut off there. But for example, if I had 4x squared plus 3x minus 5, the degree of that polynomial or trinomial is equal to the highest exponent, which is the 2. Adding and subtracting polynomials. Terms must be like terms. Understand that like terms means they have to have the same variables with the exact same powers. Okay, the coefficients can be different. Make sure you identify which terms are like first, and then add or subtract. So some examples of like terms would be 4x and negative 5x. That's one example. Say the second example would be y squared x and 5y squared x. Notice how the coefficients are different, but the variables are the same. They both have x, and they're both imaginary exponents of 1. Over here, the coefficient is a 1 and a 5. Those can be different. The y squared x has to be the same for them to be like terms. Adding, subtracting polynomials. Whoops, I'm going to move on one more screen. Here we go. What is the sum or difference? Add or subtract to find this. Notice that the x squared and the x squared, these guys are like terms. Coefficients, just go ahead and add those. So 3x squared plus 5x squared would be 3 plus 5 is 8, and your x squared comes over. The x and the power, the exponent, does not. In the second example, the x cubed y and the x cubed y, there's really a coefficient of 1 right here. So just now that you know that your terms are like, subtract your coefficients. 4 minus 1 is 3, and then your x cubed y stays the same. Classifying polynomials. Make sure the expression is in simplest form. Whoops. Oh dear. Oh, okay, here we go. Make sure that it's in the simplest form before you classify it. This is kind of blurry, but if you notice, the 4x and the 7x are like terms. The negative 1 and the 5x squared are on their own. So let's go ahead and write this in order. with highest exponent first. That's the 5x squared. The 4x and the 7x are like terms, so we can add them to 4x plus 7x is 11x. And then minus 1 drops down. So this is a trinomial because it has 3 terms, and the degree is equal to the highest exponent, which is the 2. Go ahead and try these guys. Be careful on this number 4 because there's a subtraction sign here, but put me on pause, go ahead and try them by yourself, and then resume. In 5r cubed plus 8 plus 6r cubed plus 3, notice you didn't really need the parentheses on this because there was a plus between them. So let's go ahead and identify like terms. Those are the ones that have the same variable to the same power. That would be those two, and I don't know if you guys can see that, but those two. So we end up with 5r to the third plus 6r to the third is 11r to the third, and 8 plus 3 is 11. In the second example, the like terms are, well, we better be careful. Let me go ahead and understand there's a -1 right here, which means you're subtracting the whole binomial. So we have to go ahead and do distributive property. -1 times 3x is -3x, and -1 times 5 is -5. Once you get rid of that set of parentheses, then go ahead and identify like terms, which is here and here. And we end up with x squared, putting them in order from highest exponent to least. That's gone, gone. And -2 minus 5 is -7. We have a binomial answer with a degree of 3 and a trinomial answer with a degree of 2 for numbers 3 and 4. And that takes care of lesson 8.1.